Morning, friends. Today we are discussing data warehouse schemas, which is the last bit of your first unit syllabus. Now, already you know what is schema. Okay, in database management system, we studied schema. Then it is a logical description. Okay, it is a logical description of a table in the database management system. Here it is logical description of multi-dimensional tables. Got it? Here schema in data warehouse is a schema is defined as a logical description of the database, okay, where fact and dimension tables, there are some tables, two types of tables. One is fact table and another one is dimension table. Okay, which are those? Fact table and dimension table. So these two tables are joined in a logical manner. In a logical manner, such logical description of data warehouse, okay, is called as data warehouse schema. Hence, in data warehouse, schema is defined as the logical description of database where fact tables and dimension tables are joined in a logical manner. Okay, how these things are joined in a logically, okay, we're going to see it in different types of schemas. These you can maintain data warehouses with following schemas like star schema, you are having Snowflake schema or fact consolidation schema. This is also called as galaxy schema. See, these things are the types of data warehouse schemas, or data warehouses can be maintained with the following schemas. Got it? Now we'll look one by one: star schema, Snowflake schema, and fact consolidation schema. See here now. What is this star schema? Star schema in a data warehouse in which the center of the star can have one fact table. Means, let me draw the thing. Draw this star. Assume that this is the star. Okay, so it looks like a star. Assume. Now here star schema in a data warehouse in which the center of the star, here it is the center of the star. Center of the star can have one fact table. It is called as one table. It is having, that table is called as fact table. And number of associated dimension tables. And here it is one dimension table, another dimension table. So now that fact table is associated with the number of dimension tables. Number of dimension tables. These are all dimension tables. Now this fact table this fact table is associated with number of dimension tables, like this. Now it looks like a star. It looks like a star. This structure looks like a star, hence the name star schema. Hence the name, it is a star schema. The structure resembles like a star. Hence the name is star schema. The star schema in a data model is the simplest type of the data warehouse schema. We are having galaxy schema, we are having Snowflake schema and star schema. Among all these three, star schema is the simplest one, simplest type of the schema. Why it is simple? We will going to see it in the example. It is also known as star join schema. See here now, it is also known as star join. Where is this? It is also known as star join schema, and it is optimized for querying large data sets. See here now, whenever the large amount of data will be there, data sets will be there, tables will be there, so this star schema is designed and it is optimized in a such a way that we can query the or access the large data. We can access the large data. In that way, this star schema is optimized. It is designed. Got it? So hence this star schema is also known as star join schema and is optimized for querying large data sets. Got it? So from here, this star schema in a data warehouse in which center there is a fact table, and this fact table is associated with the number of dimension tables. And this structure, the structure of this schema resembles like star. It resembles like a star. See here now, here there is one fact table, and it is associated with the dimension table, one dimension table and another dimension table. There are n number of dimension table. It can be having 2 or 3, whatever. Got it? These are dimension tables. It is associated, that fact table is associated with the number of dimension tables. Now this structure looks or resembles like a star, hence its name is star schema. Hope it is clear. And among the three schemas, data warehouse schemas like star schema, galaxy schema, or fact consolidation schema, or one more is, what is that, Snowflake schema. Okay, among these three, this is the simplest one. Got it? And this star schema is designed, optimized in such a way that it can query for large data sets. It can be used to query for the large data sets. Got it? Hope it is clear here. It is an example of star schema. Are you able to see the screen now? This example?
Yes, sir.
Okay. Here, see here now. If you go through this, here it is a fact table. This is the fact table. Here we are having a fact table. In this fact table, revenue is a fact table. In that, we are having a dealer ID, we are having the model ID and branch ID, date ID, units sold and revenue. See, all the tables are connected to this because all the primary keys are over here only. Say now, if you take a dealer table, its dealer ID is connected here, hence these two are got connected because here it is a dealer ID. Got it? Through this, it is get connected, this table. Now, we are having one more table, branch dimension. In that branch ID is there, this branch ID is get connected to this, is this. Now, this branch ID is like a foreign key and this is like this is a primary key. Hence, these two are get connected. Now, this stars fact table is connected with this dimension table. In this, we are having the one more table, dimension table, its name is product. This product ID is there, this product ID is get connected with this. Where is that product ID? Where model ID is there, date, okay. So, yeah, probably here it is model ID or whatever. Yeah, think product ID it should be there, but here it is not seeing, we are not able to see it here in this example, they might have missed it, okay. So, through this it is get connected to this table, and there are so many tables. Model table is there, model ID is there, the other thing here date is there, date ID is get connected with this, okay. So then other tables, probably product ID means it is a model ID, okay. Here it is model ID is there, no, yeah, here this model ID is get connected with this. See here now, all these dimension tables, day dimension, product table, which is a dimension table, branch dimension, it is a dimension table, and dealer, it is also dimension table. These four dimension tables are get connected with the fact table. Now, this looks like a star now. This looks like a star. Hence, this is called as star table. See here now, one more thing I want to tell you here only. Now, in this dimension table, we are having the dealer ID. Yes. One more thing, we are having country ID or location ID in this table. But this only ID is present. If I want to see the details of the location, that table is missing. That table is missing. I want to know the which country that dealer belongs to or whatever. Okay. If I want to only country ID is there, but I need the details of that country, but it is missing. Example, with respect to your database management system, as a company database I am going to take, okay, there in that table, dimension table, only employee ID is there, but the employee table you need, no? So, only employee ID 1, 2, 3, 4, 5, 6, 7, 8, 9. Assume that it is a Franklin. Okay. So, how do you come to know that in which department he is working, what is his first name, what is his middle name, what is his gender, okay, what is the gender of that employee, then date of birth, okay, department in which he is working. So, all the things are missing. So, this is the one of the drawback of this star schema. Hence, it is not properly normalized. Hence, it is not properly normalized. See here now. Here, in the following star schema example, the fact table is at the center, at which contains keys. At which it contains keys. Various keys are it contained. To every dimension table, like dealer ID, model ID, then date ID, product ID, branch ID, and others. Attributes like units sold and the revenue. These units sold and the revenue are, it is normal attributes, but all the tables are get connected to this only. Got it? If I want to know location, in which location and all, that table is missing. If I want to know this product, where is that? This product ID is there, product information is missing. Variant ID is there, variant details are missing. Got it? Like this. So hence it is one of the disadvantage. Hence we'll call it as this is not normalized properly. Got it? Now we'll see what are the characteristics of star schema. Every dimension in a star schema is represented with only one fact table. In a star schema, there is only one fact table and others are dimension tables. Hence, I made this one fact table in red color. You understood? That is the keyword. So, every star schema is represented with only one and only fact table and number of dimension tables. The dimension table should contain the set of attributes. See here now. The dimension tables should contains the set of attributes. Here the attributes is related to year, month, quarter, date, everything will be there. Here this dimension also branch ID, name, address, city of that branch, okay, and other attributes are also present. Got it? This is set of attributes. Third characteristics is the dimension table is joined to the fact table using foreign keys. As I told, see here now, these are the fact table is having the foreign key. This is the foreign key. Why it is a foreign key? Because this dealer ID is a primary key in the dealer table. Here it is a primary key, PK. It is not a American's movie, PK. It is primary key. Now here in this table it is a FK. It is a foreign key. Got it? So model ID, here it is a FK, foreign key. Here it is model ID, this is a primary key. Like this, all the tables which is having the in fact table, all the tables are get connected through this foreign key. So all the dimension tables are joined to the fact table using foreign key. The dimension table are not joined to each other. See here now. The dimension tables are not joined to each other. They are joined to fact table but not to dimension table. This table is not get connected with this. No. This table is having a connection with any of the table? No. Other than this fact table, it is not having any connection. Got it? So dimension tables are not connected to each other. Got it? Then other character is fact table would contain key. See, obviously, because these must have a key attributes. Fact table would contain key, because then only it is possible to get connected with other tables. Got it? So see here now, in spite of this date ID, if it is a only quarter or a month or a year, these are the normal attributes, simple attributes. In spite of this date ID, if we are having here in the fact table, in spite of this we are having the month, then how do you connect that with the dimension table? It is not possible. Got it? So fact table must have the keys. Next character is the star schema is easy to understand. Yes, nothing is there. If you know the primary key and foreign key concept, okay, easily you can implement this star schema, and it provides optimal disk usage. It provides optimal disk usage. So hence we are using minimum amount of the disk usage. Got it? So we are not creating the same thing again and again, just we are get connected to each other tables, dimension tables, through that foreign keys. The next difference is, where is the next difference? The next difference is the dimension tables are not normalized. Just now I told, no, these dimension tables are not normalized, because if I want to know the details of the location, I need a location table. Okay, what is the location ID, then what is the name of the location, okay, then which country it belongs to, and other things, so many things. Got it? If I want to know the country, in which territory it belongs to, got it? So all those things are missing here, hence it is not properly normalized. Hence, so for instance, in the previous example, country ID does not have a country lookup table. Country lookup table means I want to look at the country, okay, which country and what are the details of that country and all those things, but it is missing. Got it? So this is one of the, hence dimension tables are not normalized. Last characteristics is the schema is widely supported by BI tools. This schema, star schema, is widely supported by the business intelligence tools. Okay, so this business intelligence tools we are going to discuss in the last unit. Okay, do you have any doubts, friends? No doubt. Good. Kiran, Snehal, Sumaya.
No, sir.
No, sir. No, sir.
Good.
No, sir.
Okay. See, this is one of the schema of the OLAP schema, or we can call it as a data warehouse schema. Now we'll move to Snowflake schema. Snowflake schema. Now, Snowflake schema, it is another type of schema in the data warehouse. Using this also can be used for maintaining the data warehouse. This Snowflake schema in a data warehouse is a logical arrangement of tables. It is a logical arrangement of tables in a multi-dimensional database. Of course, arrangement of tables in a multi-dimensional database such that the EL diagram resembles a Snowflake schema. Means it is again one table is get connected with another table. In the relationship diagram, what do we know? So one table, employee table is get connected with department through works for. Then department table is again connected with project. Okay, controls project. Department controls project. This project table is again get connected with, what is that? Employee table. Employee works on so and so project. Like this, these tables are connected each other. So in the same way, this is also there in the multi-dimensional database. A Snowflake schema is an extension of star schema. This Snowflake schema is an extension of that what we discussed in the previous slide, that is star schema, and it is it adds additional dimensions. What it will do? It adds some more dimensions to it. It adds some more dimensions to it. Example, location. That location lookup table will be there. It is get connected with the location lookup table. Then country lookup table, and other lookup tables through that. Got it? The dimension tables are normalized. The dimension tables are normalized. Just now we discussed, no? What is not in the star schema? It is not properly normalized. Here, this Snowflake schema is normalized, which splits data into additional tables. We will be having additional tables. Got it? We'll see the example now. See, here also we will be having one factor table. Here we will be having one factor table. Factor table. See, this structure we know now. We know that this structure. I am not going to discuss about this. Already we discussed this thing in the star schema. Got it? So, Snowflake schema is an extension of what is that? Star schema. See, this is the star schema. Now, this star schema is an extension of this. Snowflake schema is an extension. Now, this location, we are having the location ID and the region, this table. And if you want to know the country, so country table is extended here, so that I can see country ID and country name. Got it? This table, okay, is having variant details. Variant details. Variant details. Got it? Just this is the only difference. Hence, these are normalized properly. This table is normalized properly. Got it? So, in the following, in this Snowflake schema example, country is further normalized into an individual table. Got it? Is this example is understood? If you understood previous example, it is nothing is there in this. Just it is an extension of that. Got it? So, we'll see. What are the characteristics of Snowflake schemas? The main benefit of the Snowflake schema, it uses smaller disk space. What is the benefit of this? It uses small amount of disk space. Second characteristic is it is easier to implement. A dimension is added to schema because just we have added already schema is there, the star schema is there. Similarly, just we need to add those normalized tables. Due to multiple table queries, multiple tables, query performance is reduced. See here now. Because why? Now, if you want to perform anything, like, see here now, in which product, okay, which product, then which dealer, he is belonging to which country or which location, means this table needs to connected with this and this table is get connected to this. So when we are merging so many tables, because again this is normalized. What it again, suppose if we are having one more key over here, so again it is having the extension, one more dimension table. So we need to connect lot many tables. When we are having such multiple tables, okay, we need to combine all those to get the information. So we need to write the query to combine all those tables. When we are writing the query for multiple tables, the query will become complex. When the query will become complex, the performance will become reduced. Is it clear now? Okay. Then last characteristics of the Snowflake schema, the primary challenge that you will face while using the Snowflake schema. What is that? Is that you need to perform more maintenance efforts because the more lookup tables. Here, this is the challenge. This challenge will be come or appears when we are implementing it or while we are maintaining it. Why? Because we need to maintain so many tables. We need to maintain so many tables. Got it? So maintaining of so many tables may required. Hence, it is performance needs more perform to for more maintenance efforts is required for that. Clear? Now, this is all about Snowflake schema. Do you have any doubt over here?
No, sir.
No doubt? Sujit?
No, sir.
No doubt. Good. Okay. Now, we'll move to consultation schema. This schema is also called as Galaxy schema. What do you know about the galaxy? We know star. Such multiple stars are get connected each other, then it is called as a galaxy. Got it? A galaxy contains two fact tables. See here now. Galaxy contains two fact tables that share dimension tables between them. How these two fact tables are connected? So one fact table's dimension tables, the dimension tables of one fact table are connected with another fact table. Got it? So it forms a galaxy. It forms a galaxy. So galaxy schema contains two fact tables that share dimension tables between them. Got it? Let me show you. Assume that this is the fact table and this is also a fact table. There are two facts table in the galaxy or fact consultation schemas. Now this schema is having dimension tables. The blue colored are dimension tables. Now these two are get connected with this. Okay. Again there are two more dimension tables. You can have any number. If you want, you can have one more. Okay. All these three tables are, so these blue colored tables are dimension tables. These dimension tables are get connected with the fact table 1. Okay, there is one more fact table 2. This is also get connected with this dimension table. This also get connected with this dimension table, and it is having some more dimension tables. These are having some more dimension tables. Got it? This forms, see here now. If you look at this, only this is star schema, one star schema, and if you look at this is another star schema. These two star schemas are combined using these two union. Okay, these two, here it is. These two dimension tables Okay, you can have a n number of dimension tables which can combine two fact tables. Got it? These are called as, okay, the using these two, those two are get combined. So it is also called a fact consultation schema. This Galaxy schema is also called as fact consultation schema. Got it? The schema is viewed as a collection of star schemas. Just now we shown. Okay, it is a collection of star schema. The name, hence the name Galaxy schema. Clear? Understood? Understood or not? Okay, fine. We'll see example. See here now. This is one fact table. This is another fact table. This fact table is having the one dimension table, second dimension table, and third dimension table. Here, this fact table is also having one dimension table, this second two dimension, this table and this table. Hence, these two table, dimension table number 2 and dimension table number 3 are combined, or it is dimension tables for both the fact tables. Okay, see here also you are having one star schema, this is also one star schema, and let me take another colors. Okay, this is another star schema, this is another star schema. These two are combined using table number 2, this table and this dimension table. Got it? Hence, as you can see in this example, there are two fact tables. Revenue, this is a revenue fact table, it is a revenue fact table, it is a product fact table. In Galaxy schema, shares dimensions. This shares dimensions are called confirmed dimensions. Is it understood? Now, what are the characteristics of Galaxy schema? The dimensions in this schema are separated into separate dimensions. The dimensions in this schema are separated into separate dimension schemas. See here now. Separated into separate dimensions based on the various levels of the hierarchies. We are having two dimension tables. These two segregates those two star schemas. Then, example, if a geography has a 4 levels of hierarchy like a region, country, state and city, then Galaxy schema should have 4 dimension tables. Got it? Here in our examples, for this product table, fact table, which is having dimension table, branch dimension, date dimension and a product dimensions. There are 3 dimension tables. Here in the revenue fact table, which is having the dealer dimension table, branch dimension table and date dimension tables. Got it? Now, moreover, it is possible to build this type of schema. Moreover, it is possible to build this type of schema by splitting the one star schema into more star schemas. Means it can be implemented, it is better to implement or easy to implement. How? Because you can segregate this star schema first, okay, then you can go for building the second star schema, then you can just combine those two. Got it? So it can be easily, you can do that. The dimensions are large in this schema. The dimensions are large in this schema because there are more number of fact tables than more number of dimension tables. Hence, which needed to build based on the levels of the hierarchy, based on the number of fact tables, you will go to build more number of dimension tables. Got it? So as the dimension increases, fact table increases, dimension tables obviously increases. Got it? This schema is helpful for aggregating fact tables for better understanding. Means aggregation means if you want to know, or if you want to get aggregated value, consolidated values, okay, for that kind of things, it helps for that aggregating facts, okay, aggregating fact tables. Got it? What is the total number of employees, what are the total number of departments, like this. Got it? This is. So these are the various characteristics of which one? Galaxy schema or fact consultation schemas. Now we'll see the last part of this, that is difference between star schema and Snowflake schema. See, first one, just let me change the color, it will be helpful for you. Yes, star schema versus Snowflake schema. The first difference is hierarchies of a dimensions are stored in the dimension table. Got it? Hierarchies means the others like location, country, those hierarchies are stored in the dimension tables. Here hierarchies are divided into separate tables. Okay, those hierarchies like a location table is different and a country table is different, variant tables are different, so it is separated. Got it? So that is the first difference. Second one is it contains fact tables surrounded by dimension tables. It is the physical structure, okay, resembles like a star. Hence, all the dimensions are surrounded by fact table. Here, one fact table surrounded by dimension tables, and which are in turn surrounded by its dimension tables. Okay, those again fact tables are connected with dimension tables. Again, those dimension tables are again connected with other lookup tables or other dimension tables in the Snowflake schema. Third difference is the star schema, only single join creates the relationship. Only single join is there between any of the table, okay, through that fact table. But here it is not like that, because again one dimension table is get connected with the other dimension table, that dimension table may contain other dimension table. Hence, it is Snowflake schema queries many joins to fetch the data, so it requires many joins. Okay, joining different types of joins will come, inner join, outer join and all. Okay, that we will study in the database management system. Got it? Then relational algebra it will come. Okay, there we will going to study all those things. Here in star schema it is simple database design, because only in the center we are having the fact table and which is surrounded by dimension table. Here this is very complex because one fact table is surrounded by many dimension tables, and those dimension tables may be surrounded by other dimension tables, and those dimension tables again surrounded by some other dimension tables. Got it? So next difference is denormalized data structure and query also run faster. Denormalized and faster. Denormalized means, as we have seen in the star schema, okay, we are having country code is there, but we are not having country details. Hence, it is not properly normalized. Hence, it is denormalized. Hence, only country this thing is there. There are no many joins. Hence, performance is faster. Here, the tables in the Snowflake schemas, the things are normalized. Dimension tables are normalized. Got it? That is high level of data redundancy, means redundancy will be more. Here low data redundancy means duplicate values are less. Here duplicate values are more, because we are having many dimension, many tables are get connected. Hence, so we'll go to particular table in spite of the in the same table, but here we'll get so much of things in the single table. Hence, we'll be having data redundancy, duplicate values. Seventh one, single dimension table contain aggregated data. So only one table will be having aggregated data, but in the Snowflake schemas, data split into different dimension tables. Datas are splitted into number of things. Here example, in the star schema, how many countries are there? Only that, from that table, okay, we can access it. Okay, how? Because we are not having the country table, but here this is split into number of dimension tables, because first dimension, then we will go to country table, key attribute, so through that we can get it connected to country table and get the information of the country. Got it? How many countries are involved, how many locations are there, like this. Eighth one, cube processing is faster because less number of tables and this thing. Here cube processing might be slower because of the complex join. Many number of tables will be there, dimension tables will be there, are connected to each other, then hence no more number of join will be there, hence it requires more slow for cubes processing. Ninth one, which offers high performance query using star join query optimization. Tables may connected with the multiple dimensions. These tables are get connected with the multiple dimensions, okay, and performance queries stars joins the query optimization. So here tables may be connected with the multiple dimensions. Here in the Snowflake schema, which is represented by centralized fact table, which unlikely connected with multiple dimensions. Unlikely connected with multiple dimensions. It is not connected with multiple dimensions because single table will be there for each and every.